Understanding R-square, F-square, and Q-square using SMART-PLS R-square statistics explains the variance in the endogenous variable explained by the exogenous variable, H. For example, a variable y influenced by x1, x2, and x3 has a R-square value of 0.623. This would mean that 62.3% change in y can be explained by x1, x2, x3. In order to make it easier to interpret, look for the arrows that are pointing towards the dependent endogenous variable. Falk and Miller, 1992, recommended that R2 values should be equal to or greater than 0.10 in order for the variance explained of a particular endogenous construct to be deemed adequate. Cohen, 1988, suggested R2 values for endogenous latent variables are assessed as follows: 0.26, substantial; 0.3, moderate; 0.02, weak. Chin, 1998, recommended R2 values for endogenous latent variables based on 0.67, substantial; 0.33, moderate; 0.19, weak. Hare et al., 2011, Hare et al., 2013, suggested in scholarly research that focuses on marketing issues, R2 values of 0.75, 0.50, or 0.25 for endogenous latent variables can, as a rough rule of thumb, be respectively described as substantial, moderate, or weak. F-square, a variable in a structural model, may be influenced by a number of different variables. Removing an exogenous variable can affect the dependent variable. F-square is the change in R-square when an exogenous variable is removed from the model. F-square is effect size. SHO2 is small, 0.15 is medium, 0.35 is large. Cohen, 1988. Q-square is predictive relevance, measures whether a model has predictive relevance or not. 0 is good. Further, Q2 establishes the predictive relevance of the endogenous constructs. Q-square values above 0 indicate that your values are well reconstructed and that the model has predictive relevance. A Q2 above 0 shows that the model has predictive relevance. In order to find out the Q-square value, run blindfolding procedure in SMART-PLS.